Okay, so I gave you this question and I asked you to solve it. So how much charges are there on the surfaces? Did you got it? Uh-huh. Yeah, but that is kind of wrong. Means it's okay only, but you equated your potential. But did you know that in earthing case, what was our condition? When we earth the body, the potential becomes zero now. Yeah. Yeah, for the earth it will become zero. But other case, since I'm not connecting, so the potential will not become equal. Are you able to get me? Okay, so look over here. So what will happen? This is, let us see. Okay. So I have charge Q1 and then I have charge Q2, isn't it? So after some time, the charge on outer surface, let's suppose the charge on outer surface be Y. मान लेते हैं कि ये outer surface के ऊपर charge कितना है? Y. Is that clear? And see, there will be some inductions also. Like I can consider due to Q1, initially what will happen? So initially first induction will happen minus Q1 plus Q1, isn't it? But the earthing will affect only this top surface. So let's suppose top surface charge becomes Y after some time. But inner surface will be minus Q1 and this one will be how much? Q1. Are you able to get me? Is this perfectly clear? Now, you know that when earthing happens, the potential of the body becomes zero during earthing, isn't it? The potential of the body will become how much? Zero during earthing. So due to all of these system of charges, let's suppose on the net, see what will happen. The whole body will have a particular net potential to be equal to zero or not. So all the charges will appear as Y over here. Is that clear? All those induction and all those charges which were appearing. See, in the case of earthing, like here I consider minus Q, then Q2 plus Q1. So what will happen? Yeah, then what will happen? Then I will have the net charge as something as Y. This will not be the total charge because the net potential of this body is how much equal to zero. It will extract all the charge. Yeah. Okay. So look over here. Then the potential of outer cell will be what? Or potential of the outer sphere will be what? Simple. Uh, First, let us consider the charge Q1 at center and potential due to this over here. So K Q1 by R2, isn't it? And due to the net charge Y, Ky by R2. So that means I got Y is equal to minus Q1. Is that clear? So this is what is the term actually. Actually, you should remember that what happens when you connect with the ground. So due to the induction, here the net charge will be what? Minus Q1. Yes, isn't it? And outside will be Q2 plus Q1 or not. Now, this Q2 plus Q1 will be extracted. Means what happens is that when you connect any body with ground, then positive charges are neutralized, while negative charges remain as it is. Are you able to get me? Because where the charge will flow, it will move from the higher potential to the lower potential. So higher potential is of Q2 plus Q1 and ground is 0. So these charges will move towards the ground. This one will not move. So that is why the net charge left on the sphere is how much? Minus Q1, which shows the reality also, isn't it? Because this will be this whole charge will become 0. Is that clear? Hmm, hmm, hmm. Yeah. So should we move to next question? Hello, बोलिए. Okay, so once again, there are two concentric spheres. Okay, but this time, this is as usual R2 and R1. Is that clear? And this has charge Q1 and this has charge Q2. Point is, now the inner sphere is trying to be made as grounded. Then find the find the charges on the sphere when the switch is closed. Do it fast. जल्दी से जाओ. क्या होगा जल्दी से? So once again, let's suppose this is Q2. So this Q1 will be neutralized. I don't know, but here let us consider that after some time, the charge on inner sphere, whatever it is, x, ठीक है, x या y जो मान सकते हैं ना. Then once again it is connected to ground. So that means that potential of inner sphere 0. Potential of inner sphere will become 0. So due to Q2 at R1, so potential of inner sphere will be Q2 by R2 as it is constant and Kx by R1 equal to how much? 0. So this implies x is equal to how much? It is Q2 minus of Q2 R1 divided by R2 lumens. This is your net charge. Is that clear? So that is my net charge after I connect. So whenever you get this kind of problem of ground or earthing, just you do what? Connect them. Means right. Consider the charges on that side to be x, and then find the potential of the system. Okay. Okay. Let us do one more problem. So there are three concentric spheres. Okay. Is that clear? Huh. And the charge on inner one is Q1. On this Q2. Sorry, not Q1. Q, twice Q, and 3Q. The radius of the sphere is R1, R2. I'll write the radius also. Okay. So this is R. This is 2R. And this is 3R. Are you able to get me? And the inner sphere is, second inner sphere is grounded. Net charge on the system. Okay. When switch, there are two switches. Okay. First one is that switch. Second one is this switch. Wow, the question. Is that clear? Switch S1, switch S2. Question is find the charges on a sphere. In first question, when S1 is closed, second question, when S2 is closed, and third question, which if I even didn't know the answer and I didn't have tried, when both S1 and S2 are closed. Okay, that will be your homework. Third one will be your homework. I don't know even the answer. There is no Google answer also. So let us try S1 and S2, but that will be your homework. Okay, but these two try it. Right. First question, when S1 is closed, what will happen? Tell me. Uh-huh. When S1 is closed, then I have to consider another charge on the second sphere. Why? And for that sphere, the net potential will be how much? Zero. Let us consider this as A, B, C. So in first case, let the charge on sphere B be Y, isn't it? But the net potential of B will be equal to how much? Zero. So how I'll write the equation? Due to 3Q, it will be 1 by, sorry, K 3Q. What? Uh-huh. How much? 2R, 3R or R? 3R, yes, because this is a hollow spherical cells. So for 3Q, the net potential over here is 3R, which will be constant. Is that clear? Then its self potential energy Ky by 2R potential, and then due to the first potential, due to this charge Q, it will be Kq by 2R only, isn't it? So you see that when I am considering any kind of inner sphere due to this charge, it is equal to their distance from center. Okay, but when I am considering from the inner to the outer, I have to consider the outer distance. Is that clear? See that when I have three concentric spheres, when I consider this charge Q1, which was located at R3. So for this Q1, the net potential over here is constant. Is that clear? So this is why I will write V is equal to KQ1 by R3, and that will be same for this and same for this charge. Is that clear? Now when I consider charge Q2, so for Q2, the potential which I get KQ2 by R2 is there for this one and till this one. But when I consider this Q2 on this one, then it's written as K. I'll consider that Q2 is located at center and I'll write KQ2 by R3. Are you able to get me? Okay. So there are two ways. One, when you are means when you are considering when you go for when you are going from outer charge towards the inner charge, towards the inside region, you will consider the radius of that charge from the center. But when I am going from inner one to the outer one, I'll consider that this charge is located at the center and their distance where I'm trying to find the potential. Are you able to get me? So this is equal to how much? 0. Are you able to get me? So can I just solve it? I can write it as Q by R plus this is Q by 2R. Why to write R also? Let us just write in terms of Q only. So Q by R plus Q by 2. Sorry, what I'm writing. Q plus Q by 2 plus Y by 2 is equal to how much? 0. So this is 3Q by 2 plus Y by 2 is equal to 0, which means Y is equal to minus 3Q. Is that clear? Are you able to get me? Minus 3Q coulombs. Is that clear or not? Do the second question. Second question. Now, for the second question, see here there is no ground. When I am considering S2 to be closed, S1 is open at that time. Okay. So there is no ground, isn't it? So first I need to do the induction process or not. So here it is Q minus Q, then here it is plus Q is on. So here once again on the top surface, how much I got? 3Q I got. So minus 3Q plus 3Q, isn't it? So you can do like this way. First thing induction like that way. And you can find the answer. But here, what they are doing, they are just connecting the inner sphere and the outer sphere, isn't it? Are you able to get me? So now what will happen? You will have to think. This is my induction process perfect. Just like earlier cases, in this one, I consider the induction process and we calculated the value to be x is equal to how much? 0. So what you got to know that whatever is my net charge, it appears on the outer charge or not, outer system or not, isn't it? Yes. So that is the induction process which we will get. So what will happen? This minus q plus q we can We can consider also, we can not consider also, no problem. But we know that when switch S2 is closed, yeah, when S2 is uh, closed, the net charge on the outer region, then net charge on outer surface is 3q plus q, which is how much? 4q, isn't it? Got it? So this one will become how much? 4q. I'll write with the green to understand S2 is closed. So this one will become 4q. And then after that, some charge will be moved out from here to there as a charge of, like we can consider that some charge will go here and there, isn't it? Yeah, so then this will be 2q as it is, and this one will I'll consider to be how much? X. Is that clear? So look over here. What we did as it is, same thing. I can consider the induction, but without the help of induction also I can do that. Considering here as q1 plus q2, q2 plus q1 minus x, and writing this as just minus q1 and then just q1 x over here. Is that clear? Are you able to get me? Uh, because it, see, we are see, because the point is, I'm telling you one thing, why I'm not considering the middle sphere. But okay, let's suppose you consider the middle square, then what it will change? It will not change anything now, because whatever is the charge which you are keeping over here. So here it is minus q and then plus q. For them, the net potential will be same or not. So that will cancel each other, isn't it? So if you get three or more, yeah. So if you get three or more concentric sphere, just consider the switch on which this they are connected. Is that clear? So look over here. Then the net potential, the equation will be potential of A sphere will be equal to potential of C. Then, so look over here. What will write over here? VA, potential of A sphere is Kx by R. Then due to 2Q, K into 2Q by it is an inner side now. So it will be 2R, isn't it? Plus K into 4Q minus X divided by how much? Once again, it will be inner region, so that is 3R equal to potential of C. So due to this Q1, I am going outer. So KQ by 3R plus treating K2Q as the center. So K2Q by 3R plus K into 4Q minus X divided by how much? 3R. Are you able to get me? So whenever the conduction will happen, if there is Q1 over here and Q2 over here, for two spheres, and if I connect with the wire, then this one will become q1 plus q2 minus x, and this one will just become x. Are you able to get me or not? Okay. So look over here. What I got. So x by r. R will I'll not consider r. So just x plus q plus 4q by 3 minus x by 3 is equal to q by 3 plus 2q by 3 plus 4q by 3 minus x by 3. Is that clear? So this one, okay, so this one will cancel. Somewhere I'm getting 1 minute. KQ by 3R, K into 2Q by 3R, K into 4Q minus X by 3R. Kx by R, K into 2Q by 2R. 2Q, CR. Oh shit, I have written wrong. Here it will be Kx now. Because the net charge on the inner sphere is how much? X. Got it? Later, I am writing for the later on. No? Yeah, so now it is. So now I'll get x minus of x by 3 is equal to 2q minus, sorry, 2q by 3 minus q. यही आ रहा ना इक्वेशन आएगा 3x minus x by 3 is equal to minus q by 3. तो x is equal to कितना आएगा minus q by 2 coulombs. That's it. Is that clear? समझ में आया? If I wrote put minus 3, so 2q minus 3q, so minus q by 3 now, and here it is. Got it? Is that clear? So we did these four types of questions will only come if they are asking you the grounded potential and all. Okay, maximum they will go to the third level, which is this one. Is that clear? But now you know how to handle any kind of question of this. Is that clear? Chalo. So now, so we did understood the case of grounded bodies or grounded conductors, and the point was we calculated the particular different cases, and we also discussed our different electric fields for all those kind of other conductors which we discussed in Gauss law and all, but we left our conducting sheet, isn't it? So to discuss in this point, so look over here, give the heading electric field due to infinitely long okay, uniformly charged sheet. ठीक है? The first case of it, conducting sheet. Is that clear? Now look. So let's suppose I have any kind of a sheet. Which is infinitely long, okay? And is charged, positively charged. So it will look like this way or not? Yes? Now, so look over here. In simple terms, if we look into this sheet in two-dimensional way, so if I take any kind of a strip, then that strip has two sections, isn't it? On top section and bottom section. And the whole charge will be distributed in that sense. Charge Q or sigma, whatever you write. Okay. So sigma and Q will be distributed in that sense, isn't it? This is my 2D view. So tell me, what will be the electric field due to this? So look over here. When I consider the conducting infinite sheet, what actually happened that the electric field on the top side also, and in that direction the normal is working, in the back side also, in that direction only my normal is there, isn't it? So then E net is how much? Because they are making 0 0, so it will be E1 plus E2, and E1 will be what? Sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Are you able to get me? So basically this gives me how much? Sigma by epsilon. Is that clear? Or in simple terms, you can understand that when we calculate for conductor, we define our electric field for the conductor now. That for the conductor, the electric field is always equal to how much? Sigma by epsilon naught, which is a constant number. Is that clear? Okay. Now, in it, I can also write, now look over here. This whole sigma is divided into two surface areas or not? So if I write in terms of Q, it is Q divided by twice a epsilon. Are you able to get me? Because the sigma value, the value of sigma is here, Qi 2. Is this clear? Now, yeah. Second case, non-conducting sheet. या इसको बोला जाता है नॉन कंडक्टिंग सीट और वन लेयर ऑफ चार्ज. Yeah. Why one layer? Because see, in conducting sheet, what happens? The charges will go on the surface, isn't it? So what happens for conducting bodies? The first surface is top one and the second surface is bottom one, isn't it? But for non-conducting body, the charges will distribute all over the body or not, and that can be seen as one layer only, isn't it? Okay. So that is why we consider non-conducting sheet as one layer of sheet. Is that clear? So when I have one layer only, when I have only one layer, then the electric field will be in only one direction, isn't it? Because I can't consider the other direction. Are you able to get me? Okay. Yeah, so E is equal to at that time sigma only sigma by 2 epsilon. Yeah. But once again, see this sigma, this time the charge is distributed all over the surface area or not? It's not on two surface area. Yes? Yeah. Yeah. So Q by 2A epsilon. So did you got one thing that in terms of charge, the electric field due to the conducting sheet and due to the non-conducting sheets, both are same. Are you able to get me? So this is very important point that in terms of Q, the formula of E is same. Array, it's same for non-conducting or conducting or one layer of charge. Is that clear? And from here, the most important thing starts, and that is the point is now instead of considering one seed, I can have a pair of seeds, isn't it? Any kind. We do not know. So let us consider combination of parallel seeds. Is that clear? So now let's suppose if I have two parallel seeds, okay, and you know that, see that in terms of Q, the conducting value, non-conducting value both are same, isn't it? Only in terms of sigma they are different. So we will consider the terms, we will consider the parallel seeds to be having only the charge Q. Is that clear? That will give us a correct analogy. Are you able to get me? I am saying that in terms of charge, the electric field of all these conducting and non-conducting seeds are same or not? Yeah, so we will consider the answer in terms of means we'll consider these all these cases. Okay, let me why I'm considering this. I have the shape and size of all objects. Control C, control V. Yeah. So these are two plates I have. First case, let's suppose this one has charge Q1 and this one has charge Q. Are you able to get me? So let us understand what actually happens when there is a combination of seeds. The first situation which we analyze or which we get it from this situation is that remember that charges the opposite on the opposite surface are always equal and opposite. The first condition is what? That whatever you do, the charges on the opposite surface are always going to be equal and opposite. Is that clear? Okay. So look over here. If I have given in this particular infinite seat and all, then 1 minute. Where is that? Uh, yeah, yeah. So look over here. When I consider the charges, then how you are going to understand that what is going to be. So look over here. What I will do after this to find or to understand that what it is trying to say us. Once again, I'll take these two plates. So look, try to see. What is the meaning of this? I'll try to make you understand. Okay. So it's saying that, sir, when you took the plates and when you placed at some distance and you put it some charge Q1 on this and Q2 on this, isn't it? Then the charge on the opposite surface are always equal and opposite. So look over here, whatever is this internal surface, I consider that there should be some charge x. How much should be some charge? X. So that will be taken from the charge q1 and it can be written as q1 minus x or not. Yes? मतलब अगर तुम्हें see, basically these plates are conducting plates. Which kind of plates? Okay. So what will happen? Basically, the charge will be distributed on top surface and bottom surface. Correct now? So when the charges will be separated, So let's suppose in the internal surface the charge came as x. So outer surface it will be how much? Q1 minus. Yeah. So then it is saying that on the opposite surface the charges are equal and opposite. On this opposite surface the charges must be equal. So x, but in the opposite side. So minus x. Are you able to get me? And that will be equal to Q2 plus x. Is that clear? Are you? Yeah, it is similar to induction only. Are you able to get me? And then it is saying that in the absence of external electric field, क्या बोल रहा है? In the absence of external electric field, the outer surface, hmm, let me write the outer surface. Okay, or let me write outermost surfaces because there can be three plates, four plates also. The outermost surface will have equal charges. Means if there is no external electric field, like look over here, is I'm putting any kind of external electric field over here? No, na. अरे मैं मतलब यहाँ पर तो नहीं है ना, तो इसका मतलब जो आउट देखो क्या है कि इसका मतलब ये है कि जो आउटर सरफेस पे ये जो चार्जेस रहेंगे वो कितने रहेंगे? इट विल बी इक्वल टू द दे विल बी व्हाट इक्वल, दे विल बी व्हाट इक्वल. Is that clear? The outermost surface charges must be equal. So here if it is q1 minus x, so for two plates I'm solving. Okay. For two plates, applying the third rule, means second rule, isn't it? That q1 minus x is equal to q2 plus x. तो तेरे को तुम्हें मिल जाता है ना x का वैल्यू. X is how much? q1 plus q2 divided by how much? 2. Are able to get me or not? क्या मेरी बात तुम्हें समझ में आ रही है ना? Plus, so you got the value of inner charge. You got means the point was just like the previous case of induction and all. We were not able to understand what can be the charge. Like we were able to understand through the help of potential. Here, there are some set of rules from which we are finding the values. Is that clear? And that set of rules is yeah. No, no means you only see there is no electric field in these regions or not. So if there are no electric field, they must be zero. That will be only zero if the charges are equal to each other. Are you able to get me? Is that clear? Okay, then the third important point is that the electric field between the plates is equal to the Q inner by A epsilon. क्या बोलता है कि सर जो electric field, look over here, here it is plus x and here it is minus x or not. So an electric field will develop from this plate to this plate. Then that electric field is exactly equal to how much? Q inner. Q inner is how much? X over here, isn't it? So x by A epsilon. Is that clear? A is area. Yeah. A is the surface area of plates. Yeah, plates basically you should tell. Okay. Is that clear? Let me write fully. A is the surface area of plates. Are you able to get me? So look over here. If I define, look over, Aram say, if I define for two plates, then this electric field equal to how much? Q1 plus Q2 divided by twice a epsilon naught. That's my electric field in the plates. Q2. Yes. Are you able to get me? Okay. So let us do one question. So this was all about your plates, quite a lot, and this only is converted as capacitor. Yes. Got the idea? Okay. Are you able to get me? Okay. Uh, okay, we were doing some questions now. We were going to do some questions. Okay. Look over here. So see that. All right, there are three plates. One having charge Q, another having charge minus 2Q. Okay, let me write on top of them. Q minus 2Q and 5Q. Then find the charge on each surface of the plates. Plates, yes. Do it fast. Should I do? Okay, I'll have to consider over here x, and this will be q minus x. This will be minus x or not. And then this minus, yeah, minus 2q plus x. Is that clear? This one will be minus 2q minus of minus 2q plus 2q plus x, isn't it? So 5q plus 2q plus x. Is that clear? So now, first step is the outer charges must be, yeah. So that means q minus x. So this will become how much? Minus 2x is equal to 7q minus q, which is 6q. So x is equal to how much? 6q by minus 2, which is minus 3. Is that right? So let us write the charges. So on here it is 7q minus 3q. So it is how much? 4q. Correct. And this one will how much? X is minus 3. 1 minute, 1 minute. Did I? Hmm, is I have done any silly mistake in minus or what? So minus 2q minus 3q. It's not possible actually. Uh, oh shit, sorry. Baba, how I changed plus 2q? This minus will convert into plus now. So it is minus 2q plus x only now. Is that clear? Got the idea? Let me see. This is how much? Minus 2q plus x. Then the minus of this whole term will be over here. So plus 2q minus x. Then it will convert into minus on this side. So 5q minus 2q plus x. Got it? So 5q minus 2q plus x. Is that clear? So this is how much? 3q plus x. This one will become minus 2x is equal to 2q, isn't it? So x is equal to minus q. Is that clear? So put over here x is equal to minus q. You are getting how much? 5q minus 3q, which is 2q. Are you able to get me? Minus q, so this will become 3q. So look over it. Net charge is still 5q or not? Then here it is minus q minus, so minus 3q, and this will become q, and this one will be minus q, and this one will be 2q. Is that clear? So these are the total charges on the surfaces. So now look over it. Can I find the electric field also? On this reason, the electric field will be in this direction, isn't it? If surface area is same for all of these, so the electric. So let's suppose the area is A. So then we get our, let us call the electric field this as first region, this as second region. So E in first region is x inner is q, so q by a epsilon naught, isn't it? That's what was our formula, isn't it? Q inner by f. And in the second region it is equal to how much? X inner is 3q, so 3q by a epsilon. Got it or not? और यही तो हम कैपेसिटेंस में करते हैं ना, Q is equal to CV, और हम क्या निकालते हैं? इलेक्ट्रिक फील्ड इज इक्वल टू A एप्सिलॉन नॉट D निकालते हैं ना, so वो इसी से आता है. Is that clear? Okay, let us do one more question. What happens if we consider the same setup in an external electric field? So I have only two setups. There is an external electric field E and this is Q, but this is twice Q. Okay, and each one have area how much? A. Got it? So question is find the charge on each surface of plate. बताओ जल्दी से. सोचो बताओ क्या होगा. You have to think what will be the equation first. Okay. How to do it? Think. Achha, first thing I need to find the charges, isn't it? So here it will be q minus x minus x, 2q plus x. यही होगा ना? Yes. And then what is the condition? Achha, here if there is an external electric field, is the charges at the outer surfaces are same? No, no. Yeah. So what I'll ignore. Yes. So here the net charges on each surfaces are not going to be same, isn't it? So what we need to do is for these kind of questions is first thing is that if you want to write, if you want to do any kind of such kind of a problem, what you need to do, you just consider, try to find the electric field at any region of the space over here. What you need to find? Electric field in any region. But mainly the electric field will exist in this region, isn't it? Yeah, yeah. So I don't know whether it is going to be same or it can be different. It can be anything. But the electric field will exist in that. And that electric field will be how much? X by A epsilon naught. Are you able to get me? Are you, are you able to get me or not? What is this electric field in reality? That electric field is created by Q minus X minus X, and 2Q plus X or not? Yes. So look over here. How I'll write that electric field? How I am going to write this electric field? It will be simple. So since this X and this X will cancel, so how I'll write? How I'll write? I'll write for the plates Q by twice A epsilon naught. This is my electric field due to the seat in terms of charge, isn't it? अभी प्रूफ किया था ना, Q by 2A epsilon naught, है ना? Are you able to get me? Then look over here. Plus the external electric field E, isn't it? E inside. Okay. And then due to the 2Q, look over it. Due to this 2Q, try to see. When I consider any region in interior region, then due to Q it is in this direction, but due to 2Q it is in opposite direction or not. Okay. So the electric field it will be due to 2Q it will be minus of 2Q by twice A epsilon naught, and that must be equal to our E inner, which is X by A epsilon naught. Got the idea? What I did first, as I know, I separated my charges. Then internal electric field is Q inner by A epsilon naught. That is given formula, isn't it? Now, for internal, select any random point in inside region, because for the plates the electric field does not vary with the distance. So select any region, select any space, and then what you do? Array. What you do is simple. Just find the electric field at any point. That electric field is simply what? For this Q, this will be in this direction, E due to Q. And E due to Q will be in this direction, isn't it? So the net electric field in this region will be E due to Q plus external electric field minus 2Q, and that must be equal to X by A epsilon. Are you able to get me? So I got how much? This is A. This is A minus Q by Y is A epsilon naught. That is X by A epsilon naught. Are you able to get me? So I got my value of X. X is EA epsilon naught minus Q by. That's my value of charge on the internal results in the presence of external electric field. Are you able to get me? Your electrostatics is over. This chapter is over. Got the idea? Let me